Hello and welcome back to Jason Live. My name is Patrick Shea, and we are here once again with our STEM career series, where we learn about careers in science, technology, engineering, and math from role models currently working in those fields. Today's role model is Dr. Anna Michel. Anna is a scientist and engineer based at the Woods Hole Oceanographic Institution. Her research focuses on developing high-tech sensors that measure chemicals in the atmosphere and in the ocean. We're going to learn all about who Anna is and what she does in just a moment. But before we do, I remind all of you out there that this event is live and interactive. You can send us questions and participate in our polls. To do so, just use the box just below this video window. So right now, we're going to meet Anna. Welcome, Anna. Thanks for joining us today.
Thanks for having me. Hi, everybody out there.
So Anna and I have been talking on and off a little bit this week, and she has been trying to bring me up to speed on all things to do with lasers and sensing, and it is fascinating. And I want her to start to share that with you because I'm still trying to get my head around it. But it's very, very cool. So I think a good place to start, Anna, is probably the big picture. What is it that you do in your research, and why is it important?
What we do in my lab is we develop new sensors for studying chemistry. So in two environments, both the atmosphere and the ocean, we want to develop new sensors so we can study chemical changes, both natural changes and also changes that are going on due to things that we have done to the world. We do this mostly by using lasers, but we also look at other optical methods. We use lasers because these can be used to do measurements that are very far away from our samples, and we can do them optically so that we don't actually have to touch our samples. You'll see in this picture here, here's a graduate student, and he's adjusting a mirror, and you can see that the light is traveling back and forth between two mirrors, and the light from the laser can interact with the chemical, and so we can make measurements without actually having to do any processing on our sample. We can use that light interaction to make chemical measurements.
Very cool. We've got some questions already coming in from our audience, so we're going to take a look at the first one here. This question is from, let's see if we can bring it up here. Now, where did it go? I know it was a question from students in Miss Border's class, and it has totally disappeared, but they were asking about the kinds of tools that you use in the Arctic. They obviously read about that in your profile and are interested, what were you doing up there?
One of the places that we've worked on in the Arctic is in Alaska, in very, very northern Alaska. We had to fly to the very northern part of Alaska and travel down a road that runs along where the pipeline is to a lake called Toolik Lake. And we used a laser there that we could shoot across the laser. It hit a mirror and came back to a detector. And that laser actually traveled a distance of about 1.2 kilometers, which to those of you that are used to thinking about miles, it's about 3/4 of a mile. And that light from that laser could interact with a gas called methane, and we could measure the methane that was coming out of that lake. So the kind of tools we use are mirrors, lasers, and all sorts of different optics like mirrors and lenses. And we also have to use things like computers to make those kind of measurements.
So why don't you talk us through, I know we've got this graphic here that shows one of the systems that you've worked on. This one's actually, I believe, a sensor that you'd use underwater. Talk us through, how does something like this actually work?
This is another kind of laser system. So this one is called laser-induced breakdown spectroscopy. And as you can imagine, if you had to say that lots of times, you get very tired of saying that. So we call it LIBS. So what we do here is we have a very high-powered laser. So what that means for us is that we have to be very careful in the lab. So we wear special safety goggles because we don't want to get that kind of laser light in our eye because it would be very dangerous. What we do is we shine that laser. You can see on this picture the green light. We can use green lasers. We often use lasers here that we can't see, but you can use green lasers for this application. We shine that laser into a sample or onto a sample. Here we're working on an ocean application, so our sample here is seawater. We shine that laser into it. We actually form a spark or a plasma And what happens is we get this white light. What we do is we break that white light down into different colors, kind of like a rainbow. We look at those different colors, and each color corresponds to a different wavelength. Well, each wavelength is a different element. And then we can tell you what is actually in that sample. So we can say, for example, in seawater, there's sodium and calcium, chloride, potassium. We can tell you what's in your sample. And so that's what we're doing in that picture. So what we want to do is develop that system into a sensor we can take into the ocean. We can, you can see here in this picture, that's Jason, one of the ROVs, and you can see the green laser light there. That's a hydrothermal vent. What we'd like to do is build a system that we could put on an ROV, and we could use it to do some chemical analysis in the bottom of the ocean. Some of my work right now is we're trying to do that kind of a system, but in the laboratory, to do sediment analysis. So some of the sediment from the bottom of the ocean, we're trying to do analysis of that. So using lasers again to do analysis of the chemistry of the ocean.
So we see here you're actually driving Jason on a previous expedition. So you are no stranger to deep ocean exploration.
Yeah, this project here was a project that I was involved with as a graduate student. They were building an underwater observatory. This is in the middle of the Pacific Ocean. And they were using Jason to deploy the different components of the observatory and also to do some other studies at the same time. And I was helping with some of the work, and I got a few minutes of driving Jason there. So that's what you see in that picture.
Very cool. We've got more questions coming in. This one also from students in Miss Bound's class. They want to know, how do you activate the lasers?
Well, there's lots of different kinds of lasers that we use. One of the kinds we use are a special kind of laser called quantum cascade lasers. And they're a tiny little laser. If you imagine the size of your fingertip, that's how small they are. If you look at this picture here, can you see a little tiny stripe on the very top of that? That's actually the laser there. And so these ones we use current to drive these lasers. So they're different kinds of lasers, but these ones are actually, we use current.
So going to the very basics of lasers, laser is an acronym, is that correct?
Yeah.
Can you tell us what that stands for, and how does it actually work? How do you go from this thing that we were just looking at, this tiny little strip on a tiny little piece of metal, I'm assuming, how do you go from that to a beam of light that can actually, do work in the ways that you're describing?
Well, lasers are all different kinds of lasers. This one here is a, sorry, I'll answer your first question first. It's light amplification by stimulated emission of radiation. But lasers are different kinds. This one here is a quantum cascade laser. We often call them QCLs. The other laser in that other picture we talked about, the LIBS, that was an ND YAG laser. That works in a totally different way that this laser works. So it really depends on what kind of laser that you're using. In this picture here, you can see the light. The QCL lasers, we can't see our light. They work in the infrared region, so they're invisible. This laser here, you can see it, and you can see that the person in the back is wearing safety goggles because he doesn't want that light to be reflected into his eyes. So lasers really work in different ways depending on the kind of laser you're working on, and they also come in different they're different colors. Again, some of them you can't see, like the infrared lasers. Some of them, this one's, you can see these are purple or blue. What we often do with our infrared lasers that we can't see, there's a problem is when we want to know where that laser is going. If we're shooting it across the room to make a measurement, or shooting it between two mirrors and we can't see where the laser is going, what we have to do is use something to be able to see where that laser is going. Now, probably a lot of you have used red laser pointers before. And what we do is, if you can see in this picture, this little red, you can see they look white here, but they're actually just because of the way the picture was taken. What we do is we line up a red laser pointer with our invisible laser. And why we do that is because we want to know where our invisible laser is going, because we can't see it. So we use something like a laser pointer to align where it's going across our mirrors, or across our room, or across our lake, so we know exactly where it's going.
Very cool. We've got our next question here from Cameron. He's in North Carolina. He wants to know, do you develop sensors that study things other than chemicals?
I personally only develop sensors that study chemicals. But when I say that, I develop sensors that study different kinds of chemicals. For example, the infrared lasers I develop are for studying gases like methane or ozone. But the LIBS spectroscopy system, those are for elements like calcium or sodium. So they're different kinds of chemicals. Also, they're for different environments. I work on sensors that go in the ocean or the atmosphere. So even though when I say chemicals, that's actually a very broad range of things that I'm actually trying to study.
So we've got another question here. And these students actually want to know, what's the most interesting thing that you have observed?
Well, probably one of the most interesting things I've observed was a few years ago, I was able to go to Beijing, China, to make some measurements there. And that we went there to study air pollution. And what was very interesting to me is that we were going there to study air pollution. And I thought that when we were going to go there, that there were going to be some days that were polluted and other days that were going to be very sunny and beautiful, like the picture you just saw. The thing that I found most amazing was as soon as the plane landed in Beijing, I looked out the window of the plane and it was completely polluted. And even on the sunniest, most blue sky days there, it was more polluted than we would ever see here in America. So I think that was one of the most interesting things I've ever observed, was just how polluted it was. And so going to make the measurements there was just fascinating.
So this seemed to be a really interesting project. Not only did you get to go to China to do it, but tell me a little bit more about it and then the techniques that you used there.
So we went to China in 2008, which was the year that the Olympics were going on. And the reason we went there was it was a very unique experiment going on in Beijing that year. Because the Olympics were going on and their air pollution is so bad, and to this day they still have a lot of air pollution problems, what the city of Beijing did was they said, well, we're going to have these events like the marathon, and how are we going to have marathon runners and other Olympians doing sports and at the same time breathing this poor air pollution? So what they said was, well, we're going to do all these things to make the air pollution really good. So what they did is they did things like they stopped all construction in the city. They only allowed people to drive their cars every other day during the summer. They started a new subway line to encourage people to go on the subway. They stopped all sorts of different things within the city to try to make the air pollution better. So it was a very unique city experiment that you would never ever see again. So what we did is we took a laser system to measure ozone over to Beijing to try to measure what would happen to the ozone, which is an air pollutant, during this experiment where the city was actually making large-scale changes to try to improve their air quality. We did an open path system, so what we did is we shot a laser across the top of this roof, out of a small building on one side, to that mirror there that you can see next to my head. It hit that mirror and it went back to the sensor where there was a detector, and we measured ozone across that roof.
Pretty amazing. So what were the results? What did you find? Were their efforts successful?
Well, what we saw was that they have an air pollution standard for ozone there. And we saw many days where the ozone was much higher than the ozone that they would like to have been below. What we did see, though, was that just in general, that when they did enact these things, what they saw was that closer to the Olympics, they were able to get these blue sky days. I think that there's been some question in general, though, on whether or not some of the blue sky days were actually caused by weather or impacted what the effect of weather is versus some of the changes they made. I think some of that is still up for discussion.
Sounds like more research is needed. We've got our next question here. This one's from Sam. He wants to know, what's the best part of your job and why?
I think the best part of my job is the traveling. I've gotten to go some really interesting places, both to do field work and also sometimes our conferences where we present our research have been in very interesting places. So I've been to some very, very interesting places all around the world.
Very cool. We've got another question here from a group of students. Actually, no, this one's from Noah. He wants to know, what types of computer programs do you use in your job as an engineer?
That's a great question, Noah. So my job, we use the same kind of programs probably a lot of you use, things like Microsoft Word and stuff to write. We do a lot of writing, which is probably surprising to a lot of you. But we use a lot of programs like MATLAB, which is a kind of like a mathematical programming where we do a lot of calculations. We use things like SolidWorks, which is what we can use to do design work.
Cool. Garrett's got a question. He wants to know, what's your favorite laser to work with?
My favorite laser, it's probably the quantum cascade laser. I think that we've done some really cool work with that because we've been able to do the open path work, which is probably one of my favorite projects to do, is to be able to, it's very rewarding to be able to shoot a laser across a lake and collect the beam back. It's pretty fun to do that. So I think the quantum cascade laser is my favorite laser.
Great. Group of students in Miss Bound's class want to know, have you discovered something that no one else had ever found?
Well, we've designed sensors that nobody has designed before. So in that way, I guess we have discovered things that no one else has done before.
Cool. And this next question here, what types of vehicles, I'm assuming underwater vehicles may be their focus here, but we can certainly talk about other types if they apply. What types of vehicles do you use while conducting your research?
Well, out in the ocean, we've used the Jason, which is the remotely operated vehicle, which is a big robot that's tethered to a ship. And when I first saw it, I was amazed at how big it was. It's about the size of your car. It doesn't look that big when you look at it from a photograph, but when you actually see it in real life, it's huge. I will be using the Nautilus ship this fall with the Hercules ROV to do another project. In terms of other vehicles, when we were up in Alaska last year, we had to use all sorts of old trucks and stuff to drive our equipment around. So you never know what kind of vehicles you'll end up using.
Very cool. We're actually going to move along here, and I want to talk about how you got to where you are in your career today, what inspired you along the way. And we've actually got a question here. A question from Sam and Mara is going to get us started. They want to know how long you've been doing this job, and did you want to do this job when you were a kid? And if you didn't, what did you want to be?
Thank you for asking that, Sam and Mara. Well, I've been here at Woods Hole for just a little over a year. Before that, I was at Princeton University for about 5 years doing atmospheric work. And before that, I was actually here as a graduate student working in laser spectroscopy. So for quite a number of years now, I've been doing this research. And I wanted to do research since I was a child. And I actually was inspired by Jason because Jason has an Argonaut program. And when I was in high school, I was very lucky to be selected to be a Jason Argonaut. And I went on a Jason program to the Galapagos Islands. And I think you're seeing a picture now where I went on one of the field campaigns or field trips to the Galapagos, where there was live broadcasting on exploration of the ocean there. And that inspired me. I remember asking one of the engineers, I said, how do I get to do this when I grow up? How do you get to do this for a job? Because I was amazed that people actually had this job where they got to drive these ROVs around the ocean. And they said, be an engineer. And that was it. I decided I was going to be an engineer.
We've got a related question before we talk too much more about your Argonaut experience. This group of students from Mrs. Bound's class want to know, what about that experience inspired you the most?
I think what inspired me the most was the fact that you got to go and explore and travel and see these places that other people didn't get to see, and you got to do this very interesting science work. That's what inspired me the most.
All right. Well, you have been answering a ton of questions already. We've got about 10 minutes left. But right now, we're going to take a break from asking you questions so that you can ask our audience some questions by way of our polls. So we're going to go to our first poll right now. That's not it. There it is. Our first poll question for all of you out there is this. Where was Anna doing field work in August 2012 when it snowed? Was it A, Brazil? Was it B, Antarctica? Or was it C, Alaska? Now, I will give you a couple of hints here. First of all, you can't just rule out Brazil right off the bat because it can snow in Brazil. It's not the kind of place you think of for snow, but it is possible. So that is not just something that you'd rule out immediately. The other hint I'm going to give while we're waiting for some responses to come in now is that Anna has already talked about this location earlier in the program. So that might be a big hint right there. So far, we've got 75% of our respondents think it's Alaska. I think I might have convinced some of them out there. 17% are guessing Brazil. That was probably my fault. I might have steered them wrong by not just eliminating that option right off the bat. But Anna, why don't you tell us what the correct answer is?
The correct answer is Alaska. I think we're going to see a picture, maybe?
There you are. And that certainly looks snowy.
On my last day of doing field work in Alaska, we suddenly had this huge snowfall. And you can see there, and I had to drive about 30 hours in this snowstorm to leave.
Sounds like an adventure.
It wouldn't have been a trip to Alaska without a snowstorm.
Cool. We're going to move on to our second poll question here, and here it is. When Anna deployed an air quality sensor in Beijing, what was taking place? Was it A, the Little League World Series? Was it B, the Olympic Games? Or was it C, the World Cup? The other way to ask this question is, have you been paying attention? Because we just talked a lot about Anna's experiences in Beijing. I will give you a hint on this one. The Little League World Series every year is in Williamsport, Pennsylvania. I don't think it has ever been in Beijing and probably will not be. So you can probably safely rule out A. The World Cup could potentially be there, but so far 100% of our viewers think it is B, Olympic Games. Anna, why don't you tell us what the right answer is?
You guys are right. It's the Olympic Games.
They have been paying attention. And there you are. So it looks like you were not only able to do some very cool research, but you got to experience some of the games.
And that's actually at the rowing event. They built a rowing lake, and that we got to go to some of the games. It was hard to get tickets, so we did get to see a few things, though.
Awesome. We've got our third poll question here. When Anna was in high school and was a Jason Argonaut, where did she explore? Was it A, the Galapagos Islands? Was it B, Easter Island? Or was it C, Hawaii? I'm realizing I spelled Galapagos wrong in the little widget where we have kids vote. Got it right in the graphic, though. My hint for all of you watching out there on this one is Jason has been to 2 of these 3 places in its history, and Easter Island is not one of them. Hint number 2 is Anna has also given you this answer during the program, so if you've been paying attention, you should know. And right now, 92% of the folks out there think it's Galapagos, 8% think it's Hawaii. Anna, why don't you tell us what the right answer is?
The answer is Galapagos Islands.
Very cool. Although any of those would be really neat places to visit.
And I'd love to go to Easter Island.
Yeah. I actually got to go to Hawaii a couple times on Jason trips. So just more adventure. We're going to move along now and continue to take your questions. Continue to send them in. We've got a few minutes left here. Right now, we've got a question that I'm going to post up here. And this is a question about the future from I believe this was Mrs. Stanger. She wants to know, what do you think we will see in terms of future underwater exploration vehicles?
That's a great question. I think that we'll see more vehicles that are unmanned. I think we'll see vehicles that can take lots of instruments that we'll leave out for longer periods of time to get more measurements in the ocean. And that's actually where my research really fits in. I think that we will need more chemical sensors to put on these kinds of instruments that we're going to leave out to be able to make measurements for long periods.
Cool. We've got another question here. This one's from Houston's 6th grade talented and gifted class. They want to know, do you ever get bored with your job?
That's a good question. I don't think I ever get bored with my job because it's always changing. We're always thinking about the next idea, and we're always trying to get funding to fund that next idea. And I think a lot of people think of science or engineering as careers that can be lonely, and I don't think that's true at all. You're always working with other people. You're always collaborating with other people. Before I did this today, I was on the phone with a collaborator from Princeton. We were talking about a project that we're trying to put together. So you're always working with other people. So I don't think, no, you don't ever get bored. I think it's the opposite. I'm always trying to slow down.
Yeah. Ask this a slightly different way. Do you ever get frustrated? What's the most challenging thing about your work?
The most challenging thing is funding. Trying to get enough money to do your research and to travel, to do the projects, and to fund people to help you do your research, students and technicians and engineers. So you can't do it all yourself. So you need people to work with you. So being able to get enough funding to pay for all that, that's the hardest part.
Makes sense. Our next question here from Kayla, Zach, Cody, Elsie, and DJ. They want to know, what's the scariest time you've had doing your research?
I'm not sure I have an answer for that one. The scariest time? I don't think I've ever had anything that's really scary.
Not even that 3-hour drive in the Alaskan snowstorm?
I wasn't driving. I was with a driver. I don't think I've ever had anything really scary happen to me. Luckily. I'll let you know if something happens, but hopefully not.
All right, we'll be waiting for that scary moment to happen.
I'm pretty brave.
Our next question is from Jordan. He wants to know, how cold was the water in the Arctic? He would like that answer in Fahrenheit.
Well, we were working at a lake, and it wasn't frozen, and so the water was probably about 40 Fahrenheit when I was there. I was there in the summer, so it wasn't that cold. And you'll probably be amazed to think that because there was a water restrictions where we were, because everything at the field station had to be taken in and out of the field station because they don't want to pollute anything. So if you use any water there, it has to be saved and taken out. So you could only have a shower there twice a week for 2 minutes. So instead what people did was they would jump in the lake and then go have a sauna. So people got in that very, very cold water, and I didn't do that though. It was a little too cold for me.
Yeah, that sounds scary.
Yeah. See, I guess that I didn't do it though. So.
Yeah. Cool. We're gonna shift gears a bit. Jelena, grade 2, wants to know, what makes you unstoppable as an engineer?
That's a great question. I really like being an engineer, and I really like doing the research. And I think that what keeps me going the most is knowing that there's another experience coming up. So when we write our grants and we write about our research projects, we know what's going to happen. So I know, for example, that this fall there's a trip coming up, and I know I need to work towards that. So I think that keeps me going, is knowing what's coming next, what we have to work towards.
Great. Well, we're almost out of time. In just the couple minutes that we have left, I'm wondering if you have any advice or thoughts for our audience out there, some of whom you may have inspired today to follow in your footsteps and be an engineer. What do you have to say to them as they're listening and watching today?
I think it's really important to find a career that you really want to do and work hard at what you do. And it's also important to have other things in your life that you really enjoy and do those things too. Like if you like science and math, it's also great to do music or a foreign language and do other things too. I played the violin for a long time, and I also really, really loved taking French class when I was in high school and college, so I did that for a long time. So I think it's good to have a lot of balance in your life too.
And what kind of things do you do these days to keep balance in your life? What do you do when you're not researching and building sensors and traveling around the world?
I have a 4-year-old son who keeps me very busy.
That'll do it.
So he is my after-school activity, shall we say.
Very cool. Well, that is actually all the time we have for today with Anna. Thank you so much for joining us. It's been fascinating to learn about your work, and I'm sure you have inspired many, many students out there to, if nothing else, check out potential careers in engineering. So thanks for taking the time.
Thanks for having me, and I hope everyone learned something today.
Awesome. Our live STEM Role Model Career Series continues next week with ocean engineer Clara Smart. Clara is currently working towards her PhD at the University of Rhode Island. She is also a member of the Nautilus Corps of Exploration. She's been on board the Nautilus for many expedition legs over the last few years, so lots of experience there. She's served in the role of navigator and helps to create high-resolution maps of the seafloor. So join us live for that next Thursday, December 12th at 1:30 p.m. Eastern to learn all about Clara and her ocean engineering career. That is all the time we have for today. Once again, thanks for joining us. My name is Patrick Shea for Jason Learning. We'll see you again next time. Take care.